Hey everyone, and welcome. Today, we're diving into a technology you've definitely heard about, but maybe don't fully get past all the crypto headlines. We're going to demystify blockchain and really peel back the layers to see what could be a massive shift in how we trust anything in the digital world.
Really think about that for a second. Every single time you post something, buy something, or move money online, you're putting your faith in a third party. You're trusting a social media giant, a huge retailer, a bank. Our entire digital world is pretty much run by these central gatekeepers. But what if it didn't have to be that way?
And that right there is the fundamental problem blockchain was invented to solve. See, our current internet, what people call Web 2, it's super convenient, no doubt. But that convenience has a price. When you pile up all that data in just a few places, you create these giant targets. It's why we see massive data breaches, why platforms can censor people, and it all leads to this basic truth. We don't actually own or control our own digital lives.
So here's our game plan for today. We're going to start with this crisis of trust that really set the stage for blockchain. Then we'll get into what this unchangeable ledger actually is and how in the world it stays secure. After that, we'll look at the real game changer, smart contracts. And finally, we'll zoom out and see what our decentralized future might look like.
All right, let's kick things off with our first big topic. The entire promise of blockchain technology is basically a direct answer to this digital trust problem. It's all about building a new version of the internet, one where we don't just read and write content, but where we actually have provable digital ownership of our stuff.
So what is a blockchain when you boil it all down? Let's just forget the jargon for a minute. At its heart, it's just a new kind of record book, a new type of database. But what makes it so special are these three words right here. It's shared, which means no single company owns it. It's distributed, so it lives on thousands of computers at once, meaning there's no central server to hack. And most importantly, it's immutable. Once a record is written, it's basically set in stone. You can't change it or delete it.
Okay, so that's what it is. But how does it actually work? How do you create this permanent, verifiable record that a whole network of strangers can trust without a boss in the middle? Well, that brings us right to Section 2, the Unchangeable Ledger.
The process is actually pretty elegant and straightforward. First, a transaction, could be anything, money, data, you name it, gets put into a new block. Second, before that block gets added to the chain, all the computers on the network have to agree that it's legit. That's the super important consensus part. Third, once it's validated, that block is locked to the previous one with a unique cryptographic link. And finally, the whole updated chain gets broadcast to everybody, so everyone has the exact same up-to-date copy.
Now here's something most people don't know. This idea is way older than Bitcoin. The real breakthrough happened back in 1991, when these two cryptographers, Haber and Stornetta, figured out a way to timestamp digital documents you could prove they hadn't been tampered with. The mysterious creator of Bitcoin, Satoshi Nakamoto, was a genius for taking their concept and even citing their paper and applying it to create digital money. Then, of course, in 2015, Ethereum came along and took it to a whole new level, turning the blockchain from just a record book into a programmable world computer.
So how does a network with no central boss, no CEO, keep itself secure and in order? That's what we're tackling in Section 3. And the answer really comes down to two incredibly powerful ideas working together: cryptographic hashing and consensus.
Let's start with hashing. The best way to think about it is like a unique digital fingerprint for any piece of data. You could take the entire Library of Congress, run it through a hash function, and it spits out this one-of-a-kind code. But here's the magic trick. If you go back and change just a single comma in one of those books, the fingerprint, the hash, becomes completely different. And that's how the chain is so secure. Each new block holds the fingerprint of the block before it. So if anyone tries to mess with an old block, its fingerprint changes, which breaks the entire chain. And the whole network instantly knows something is wrong. It's just brilliantly simple and incredibly secure.
Now, the second piece of this security puzzle is consensus, getting everyone to agree on what the truth is. The original method, the one Bitcoin uses, is called proof of work. This is where miners use super powerful computers to race to solve these insane math problems. The winner gets to add the next block. It is unbelievably secure, but it has one massive downside. It uses a jaw-dropping amount of electricity. That problem is exactly what led to the next big thing, proof of stake. Here, instead of burning energy, validators lock up their own crypto as collateral. They have skin in the game. If they act dishonestly, they can lose their money. It achieves security through economics, and it uses a tiny, tiny fraction of the energy.
The leap from just a secure database to something so much bigger happened because of one single innovation. In Section 4, we're talking about smart contracts, the technology that lets us write rules and logic directly onto the blockchain, creating, literally, code you can trust.
This concept was actually dreamed up way back in the 90s by a computer scientist named Nick Szabo, and he came up with this perfect analogy: a vending machine. Think about it. It's a contract. If you insert the right amount of money, that's the condition. Then the machine is programmed to give you a snack. It just happens. There's no person in the middle you have to trust. The rules are just built into the machine. The code is the law.
So, more formally, a smart contract is a self-executing program. The terms of any deal are written right into the code. And because that code lives on the decentralized blockchain, once you deploy it, it's basically unstoppable and unchangeable. I mean, just let that sink in for a second. It's a contract that enforces itself. It guarantees an outcome without needing lawyers or courts or trusting that the other person will do what they promised.
And this is not just some sci-fi idea. Smart contracts are out there right now, changing how things work. In finance, they run the entire world of DeFi, automating loans without needing a bank. For supply chains, they can track a product from the factory to the store, fighting fraud. They can automate real estate deals and even help secure things like medical records or voting systems. The big theme here, they get rid of the expensive, slow, human middleman.
Okay, so when you put all these pieces together, the secure ledger, the cryptographic security, the programmable smart contracts, they start to build a whole new digital world. In our final section, we're going to look at what this decentralized future might hold, touching on Web3, a whole new kind of asset, and the really interesting overlap between blockchain and AI. The grand vision here is called Web3. So if Web 1 was the read-only internet of the 90s, and our current Web 2 is the read-write internet, where we create content on platforms that other people own, then Web 3 is the read-write-own internet. And that own part is everything. Instead of your data being stuck inside one company's walls, blockchain lets you have verifiable ownership of your digital stuff, an identity you can take anywhere. The trust just shifts from corporations to the code itself. And one of the biggest trends making this real is what's called tokenization of real-world assets. It sounds complex, but it's just the idea of taking ownership of something physical, like a piece of real estate, a painting, a government bond, and turning it into a digital token on a blockchain. Why is that such a huge deal? Well, it takes these things that are usually hard to sell and available to only a few people and makes them easy to divide up, trade, and access for anyone in the world 24/7. This isn't a fringe idea. We're talking about rewiring the entire plumbing of global finance. Now, this brings us to a super timely question, right? With AI exploding everywhere, you have to wonder, can't you just ask an AI to, build you a new blockchain from the ground up? Let's tackle that head on. And the short answer, at least with today's technology, is no. AI is an absolutely incredible tool. It's like a super-powered assistant for developers. It can write smart contract code, it can help find bugs, it can make things more efficient. But it's an assistant, it's not the architect. You still need a human to have the big idea, to design the rules of the system, to innovate on the protocol. The real future isn't AI versus developers, it's the two of them working together. Human creativity is still the one in the driver's seat.
So if there's one thing to take away from all this, it's that blockchain technology is growing up. It's moving way beyond its first life as just a playground for speculative crypto trading. It's now being built into the foundations of our global digital world, becoming critical infrastructure, just like the internet itself. And that really leaves us with one last big idea to chew on. We're moving into a world where trust isn't just a handshake or a promise from an institution. It's something that can be written into transparent, verifiable code that anyone can see. And as that idea really takes hold, the question isn't if it's going to change things, but what part of our world is it going to decentralize next?